Hi, for this video, we will look into quasi-simple grammars. Okay, so we want to see what is the difference between the quasi-simple grammar and a simple grammar itself. Okay, first we look into the definitions of a quasi-simple grammars. So it is a grammar which obey the restrictions of simple grammars, but which may also contain rules for in the form of non-terminal followed by epsilon. So what does it mean here? Quasi-simple grammar actually use the restriction in simple grammar, but it add on another rules which allow a non-terminal to goes to epsilon. Okay, so if you can still remember, what are the restrictions for simple grammar? There are two. One, the restriction for simple grammar, it says that it must be in the form of non-terminal goes to terminal followed by any terminal and non-terminal, which is alpha. Okay, alpha. And the second restriction, the second rule, is says when they have more than two or more the same non-terminal, then the first string of the right hand side of the grammar must not be the same. Okay, for example, if you look into G14, grammar 14, rules number 1 and rules number 2, they have the same non-terminal, which is S, but the first string of the right hand side of the grammar is different. The first rule A, the second rule is B, so it is different. So that is the second rules for simple grammar. But for quasi-simple grammar, they add on another rules which allow the non-terminal to goes to epsilon. Okay, so in this case, we can see G14 is quasi-simple grammar because they have rules number 4. Non-terminal goes to epsilon. Okay, so now we want to see what is selection set and a follow set in quasi-simple grammar. Okay, for a selection set in a simple grammar is the same with a quasi-simple grammar. Okay, how to identify selection set? Okay, for example, in rules number 1, the selection set is A. So we determine it by looking at the first string of the right hand side of the grammar, okay, or the production rules. The selection set of second rules is B. The selection set of the third one is C. The selection set for number 4, we don't know because it is epsilon. Epsilon is null. Okay, we didn't know. So that is why we need to identify the follow set for rule number 4 in order to know what is the selection set. Selection set is important when we want to do a derivation tree. We want to know which rules that we should instantiate first. For example, in G14, they have two rules that start with S. So we want to determine which rules that we should instantiate first, whether S from the first rule or S from the second rule. So that is the purpose of selection set. But we didn't know a selection set for number 4. So that's why we need to identify the follow set. Okay, so what is a follow set? The follow set of a non-terminal A, okay, A here represent a non-terminal, okay, designated by fold A. So fold A actually is follow A. Is the set of all terminals. So remember, in the follow set, it only contain terminals, symbol only, okay, or and marker, okay, either terminal symbol or end marker. So which can immediately follow an A in an intermediate form derived from S. So follow set is any terminal that follow right after non-terminal A or any non-terminal S as well. Okay, so follow actually is represented for any non-terminal inside the grammar. So in this case, the non-terminal is S and A. So we can have follow A and we can have follow S as well. Okay. All right. So the keyword is here. Follow an A in an intermediate. Immediately follow an A. So immediately, right after that non-terminal. Okay. If we say follow A, means that what are the terminal that follow immediately after non-terminal A? If we say follow S, so what would be the terminal that followed right away after non-terminal S? Okay. So the answer is here. The follow set of S is A, B, and N marker. The follow set of P is A, B. So how we get this? How do we get A, B, N marker? How do we get A, B? Yeah, for follow A. So, okay, the step is we must start. Okay, it is derived from. We must start from S, N marker S, where S is the starting non-terminal. So we need to do a derivations starting from S. So we need we sometimes we didn't need to derive it until the end, but we can see it in the intermediate process. That is what it means here, intermediate process. Okay. Okay, let's look into the first one. We want to see follow S. Okay, follow S. Okay, let's start with S, N marker. Okay, so S for the first rule, it goes to A, capital A, S. Okay, then we can we can instantiate this A, become A, C, A, S. Okay, and we have, don't forget to have another S here at the back. See? So we instantiate A in front here. Okay, so we instantiate this A, become A, C, A, S. Okay, this is C actually, C, A, S. Okay, then don't forget the end marker, yeah. Alright, then we can instantiate further the S in this derivation, A, C, A, S. So instantiate the S at the end there, become, using a first rule, become A, become A, become A, AS. Okay, AAS. A, A, S. Okay, it's quite difficult. Alright. Now, okay, end marker, don't forget at the end. Okay, so this is one of the derivations. We also can derive the S here, become A, C, A, S. So the S you replace with the second rules, which is P. Okay, so in this case, follow S is equals to, okay, the letter that immediately follow after S non-terminal is A, N marker, and also B. Okay, so it is A, B, and N marker. Okay, so that is how you write follow S. to find the follow S. Okay, now let's look into follow A. How to find follow A? So we also start from S. Okay, always start from S and marker will follow. It will follow. So S goes to S can goes to A, the first row A, S, capital S, and marker. And A, we can replace the S with the S with A S, the first rule as well. So write down. So the S here, replace it with A S. Okay, A S. Okay. Then we also can replace the S there. A. This S here become B. Straight away. Yeah, B. Okay. And marker. So what would be the terminal that follows straight away after after non-terminal A? So in this case, after non-terminal A is A, okay, normal, and for the second one is B. Okay, this is letter non-terminal A, so the terminal follow right after the non-terminal A is B. So this is letter A. The terminal that follow immediately after non-terminal A is A. So means that follow A is A, B. Alright. Okay. So this is follow A. So we know that we find this follow A and follow S. We want to look actually what is the selection set for rules number 4 for the epsilon. What does it mean? Epsilon here is to determine what would be the terminal symbol that will be used to indicate which rule that we need to derive first, which rule that we need to instantiate first. Okay, so the selection set is used to determine which path. Okay, so here we can say that the selection set for number 4 or rules number 4 is because the rule number 4 is with a non-terminal A, so we say that we use follow A. So is equals to for A. So actually is A, B. Okay. So now we know that the selection set that we can use for rule number 4 is A or B. Okay. Now we want to see how actually we can use that the importance of identifying the follow and selection set when we want to build a derivation tree. Okay, for example, we want to find a parsing for string A, C, B, B using building this derivation tree. Okay, for example, from the rules here, from the rules 1, okay, we can instantiate the S become AS. Okay, this is from the first rule because the first string is A. So we can straight away determine which rules to derive first. Is it the rule S for the first rule for S or the second rule? Because first rule and second rules start from S. So which one to use? Is it the first rule or second rules? So in this case, because of the start string here, the string that we want here is A. So we are using rules number 1. Okay. Okay. So we use AS. Yeah. So this is A. All right. Okay. Next string is C. Okay. Next string is C. So we have a derivations for A. We want to determine A here. Okay. which rules that start with a non-terminal A that we need to derive, either rules number 3 or rules number 4. Okay, so rules number 3, the selection set is C, while the rules number 4, the selection set is A or B, which is just now is epsilon. Okay, we find the follow set. For A, we get A and B. So it means that in order to determine the selection set, epsilon actually start from a terminal A or B. Okay, but for this case, the next string is C, so we choose rule number 3 because rule number 3 is start from C, okay, then A and S. Okay, that is why it is important to determine what will be the selection set for each of the rules, and it is also important to determine what will be the selection sets of the epsilon, because here we want to determine whether we want to use a rule number 3 or rule number 4. We will use rule number 3 if the string that we want to the input string that we want to use is C. But if the input string that we want to use is A or B, then we need to use rules number 4. Okay. Now we look into the next one. The next input symbol is B. Okay, so we have a derivation. We need to derive from A. So now we can choose from A, but the input symbol is B. So which rule you want to use? Either the rule 3 or rule number 4. Rule number 3 is CAS, so it starts with C. So we cannot use rule 3. So we use rule number 4 because rule number 4 said that A goes to epsilon. The epsilon actually, the follow set for the epsilon actually is A or B. So now when the input string is B, you choose rule number 4. Okay, so A, C, now the value is epsilon. Okay, so you don't put B here because the original rules say that A goes to epsilon. But you only use the follow set to determine which rule you want to instantiate. That's it. Okay. Alright, next the input symbol is B. Okay, so you have the non-terminal here is S. Okay, so which rule to use? Okay, either rule 1 or rule 2. Rule 1, it must start from A, but rule 2 is start from it is a B. So you replace S with B using a rule number 2. Okay, next one. The input symbol is B. Okay, then the rule for S will be rule number 2. So you can get A, C, B, B. So you normally don't write A epsilon B B. No. For string, you normally ignore the epsilon. You just write A, C, B, B. Okay. So that is why we need to find the selection and follow set in the quasi-simple grammar. Okay, now we want to look into a push-down machine for a quasi-simple grammar. It is quite similar with a push-down machine for simple grammar, except for this rule number 4 here. Okay, all right. Normally, okay, in a simple grammar, usually in the simple grammar, if we look into this rule, we will use a replace, and retain. Okay, like in this example, like the first rule here, which is the first column here, we replace SAA and retain. Okay. In the rule number 2, in the second column here, we replace with B and retain. But not in the case of rule number 4. So in the rule number 4, so which one would be the input symbol? Again, we using the follow A just now. Okay, follow A saying that it is either A or B. So means that it should be here. Okay, A or B. Okay, now for epsilon, we did not use replace and retain, but instead we are using pop and retain. So we don't want to replace because it is null, so we don't replace it. So we just pop. Every time we see a letter input symbol A, and the push down machine should pop and retain. So this will be the only difference with the simple grammar. Okay, when they find the epsilon, they will pop and retain. The rest will be the same. Okay, the rest of the element in the cell here will be the same as the simple grammar. Okay. Now this is a recursive descent for quasi-simple grammar. It's also similar to the simple grammar, except for the rule number 4 there. Okay, if you look into the simple grammar, for each of the non-terminal, we need to create a method for it. For example, rule number 1 and 2, we create one method. Rule number 3 and number 4, we create another method. So this is why you have C method for S and method for A. So this void method for pass actually is to receive the input symbol. This is the first one, receive input symbol. Okay, now the method S will be no problem, is similar to the one in a simple grammar. Okay, so we just read the input. If the input is A, which is the first one, then we read the input and followed by A and S. Okay, that's the end of rule 1. Else, if the input is B, so this is already goes to rules number 2. Otherwise, reject. Okay, now the concern is on the void method A because of the rule number 4 here. We want to see how it represents. Again, we need to use the selection set A, B. Okay, so if the input symbol is C, so this is the rule number 3, then you get the input, then followed by, so we perform function A and we perform function S. Okay, then that is the end of rule number 3. Okay, now we go. Else, if the input is A or B, because the rule number 3 said if the input is C, then you do this. But if the input is A or C, or A or B, then you do nothing because it is null. Do nothing, epsilon. Okay, so else if input A or input B, so at the end of the if statement, it indicate by semicolon. Normally if statement, they don't, you normally have another implementation inside it in the curly bracket, but in this case, because it is epsilon, that we straight away end the statement with a semicolon. Means that you do nothing. Yeah. Else, if it is not A, if it is not B, if not C, then reject it. So that is recursive descent for quasi-simple grammar. So this is the programming part of how you want to pass a language using quasi-simple grammar. So the conclusion here, simple grammar and a quasi-simple grammar is similar, except that it add on another rules to allow epsilon. Okay, when it allow epsilon, then you need to find what would be the follow set for that epsilon. Follow set means that what are the terminals will be used to indicate what they call that selection statement. Okay, so a selection set in order to write a pushdown machine, to write a derivation, and also to write a recursive descent. So they need the follow set to determine. Okay, so that is all for a quasi-simple grammar. For next video, we will look into LL1 grammar. Thank you very much.